Our next section is infinite geometric series. So we're going to look at finding the sum of an infinite geometric series. So hopefully infinite makes you think goes on forever. So surprisingly enough, the definition for an infinite geometric series is a series that never ends, a geometric series that never ends. There are two different types of infinite geometric series. One is convergent, and this is a series with a finite sum. So even though the number of terms never ends, when the common ratio is less than 1, the absolute value of the common ratio is less than 1, it approaches one single number because each term will start to get smaller and smaller until essentially the terms are 0. A divergent infinite geometric series would be one where the ratio is greater than 1, or the absolute value of the ratio is greater than 1. So the numbers keep getting larger, so the sum keeps getting larger as well. On the bottom here, if the ratio is between -1 and 1, if the absolute value of the ratio is less than 1, then to find the sum, you take the first term divided by 1 minus r. So it's very similar to finding the sum of terms in a geometric series, except for that numerator in our other formula is now gone. So taking a look at two series, we're going to determine if the series would converge or diverge. Our first series, I'm going to find the common ratio. -12 divided by 4 is -3. So that would have, as I'm looking, that is not my next ratio. So we'll just say that this is supposed to be 36, and then we'll have a common ratio. So since the ratio is -3, that the absolute value of that is greater than 1, so this would be a divergent series. Our next series, 1 divided by 10 is 1/10, 1/10 divided by 1 is 1/10, and so on. So the common ratio is less than 1, so this would converge. So to find the sum of the infinite geometric series, we need two pieces of information. We need the first term, which in our case is 3, and we need the common ratio. So 1.2 divided by 3, I think would give us 1/4. Let me double check that. Nope, 4/10. 0.4. So our common ratio is 4/10. So then when we find the sum of the entire series, we take the first term divided by 1 minus the common ratio. So 3 divided by 6/10 would give us a sum of 5. On our last example, we're going to look at finding the sum of an infinite geometric series using sigma notation. Very similar, except for we just need to calculate the first term. So substituting 0 in for k, anything to the 0 power is 1. And then our common ratio, remember, is the base of the exponential, which in our case is 1/10, or if you prefer the decimal form, it's a little easier to use with our formula, would be 0.1. So the sum of the series would be our first term divided by 1 minus our common ratio. So we would get 1 divided by 9/10, and that would give us 1.1 repeating. Or we can turn that into a mixed number, and that would be 10/9.